Performance test of a non-positive displacement pump for MLab 2. Non-positive displacement pump, ito yung mga centrifugal sa rotary. So, unahan natin yung centrifugal pump. Centrifugal pumps have been adapted almost exclusively for all power plant pumping application within the limits of their satisfactory design. Their popularity has been due to the simplicity of construction. There is only one rotating element and no valves to adjust. Fluid enters the impeller of a centrifugal pump at the eye. Ito yung eye, ito yung figure, volume type centrifugal pump, or center of the impeller. Ito yung impeller, yan sa loob na yan. Ito yung volute casing. There it is picked up by impeller vanes, ito, and travels along the vane. With the impeller rotation on figure 1, the absolute path of the fluid resembles a spiral and the flow is in the plane perpendicular to the shaft. This type of impeller is called radial flow impeller. The fluid pressure and velocity are increased during travel through the impeller. After leaving the impeller, the fluid enters the volute where a major part of velocity is transformed to pressure energy. The fluid leaves the pump through the outlet nozzle with some velocity energy with more pressure energy than it had upon entering. Kasi inad siya nung power, yung work done on the fluid. The increase in pressure energy acquired as the fluid flows to the impeller is due to centrifugal force exerted on the fluid. It is a function of velocity squared. Since the kinetic energy developed by the impeller is also a function of the velocity, the total pressure developed is proportional to the velocity squared. Water entering the eye of the impeller actually has its direction changed by the shape of the impeller, so that it enters the vent section with approximately radial velocity v1 of figure 1. So, in fluid machinery, this is furtherly discussed. This is the velocity diagram. Vector U1 is the velocity of the eye of the impeller, thus the relative velocity of the water with respect to the vane is C1. The angle beta 1 is determined by the relative velocity vector and must be the angle of the vane at the point of contact with the water to prevent a loss from shock. So check the fluid machinery topic for the velocity triangle. At the periphery of the impeller, the water leaves in the direction indicated by the vane producing angle beta 2 and vector C2 relative to the rotor. By combining the velocity of the impeller periphery U2 with relative liquid velocity, we obtain the absolute velocity. This is using Pythagorean theorems or vectors. As might be expected, the direction and magnitude of the vector C2 of an actual impeller are somewhat different from that for the theoretical vector due to imperfect hydraulic conditions and to turbulence. So this is theoretical, yung actual niya is yung may nag-iiba yung mga direction niyan. So sa picture, makikita mo yung arrow naka-dotted line. Parang actual velocity. The velocity of the stream at the impeller periphery must be substantially converted into pressure energy if suitable efficiency is to be obtained. The two methods of accomplishing this conversion, volute casing and diffuser casing, provide one means of classifying centrifugal pump. So the pump shown in figure 1 is a volute pump wherein the conversion from velocity to pressure energy takes place only in the outlet nozzle of the volute dito. So dito nag-expand siya, so yung velocity bumabagal, so nagiging pressure. Diffusers in figure 2 are fastened to the casing and surrounds the impeller. The expanding passages of the diffuser have an included angle about 11 degrees and convert mass of the velocity energy into pressure energy with negligible radial thrust. A collecting chamber of volute shape surrounds the diffuser and the final conversion takes place in the nozzle outlet of the collecting chamber. For the characteristic of centrifugal pump, curves, mga curve niya, shapes for the characteristic of centrifugal pumps are a function of the inclination of the impeller vanes employed. So most impeller have backward curve vanes. Ito yung backward, ito yung quantity head, yung performance curve niya. So ito yung radial, backward, and forward curve impeller vanes. So beta is less than 90. So ito yung sa backward, baba. So ito naman sa 90 degrees, ito yung radial. This is naman more than 90 degrees, and beta 2 is for forward curve. So most impeller have backward curve vanes, but the vanes may also be straight, radial, or forward curve, figure 3. Fans are frequently manufactured with forward curve kasi mostly maliliit. So all the characteristic head curves had the units of head and feet and capacity in volume for coordinates. This is in accordance with the general custom since a centrifugal pump displaces volume of fluid against feet of head of the fluid pump. That statement cannot be emphasized strongly since it is the basis for the calculation of many power pump of problems. So, feet or meters. Okay. There is a vast difference between volume flow and weight flow and between head and feet and head and pounds per square foot. A given volume of flow will represent fewer pounds per hour at high temperature than at low temperature. Okay? Kasi ang rating kasi is volume. So, mass flow ang magbabago. Likewise, depende sa temperature. Likewise, a given head and feet will represent fewer pounds per square inch at high temperature than at a low temperature. But regardless of the temperature of the fluid, a centrifugal will displace a definite volume against a certain feet of head at a particular point on its characteristic curve. Water horsepower or brake horsepower varies as the specific gravity when flow is expressed in gallons per minute and head and feet. Therefore, the horsepower is a function of temperature. So example number 1. Determine the rated capacity in pounds per hour and head in pounds per square inch for the pump in figure 4 when the water is at 350 Fahrenheit. Also find the brake horsepower. So ito yung figure natin. Performance curve for a 4-stage boiler feed pump rated at 450 RPM. Yan, 1,000 feet head, 71% efficiency, and 3,550 RPM. Okay, so ito yung rating niya. Rating niya laging nasa gitna. 450 at best efficiency, 1,000. So yan ang rating niya. So speed is ng impeller is 355 RPM. So wait, wala palang solusyon to. So wait na. So given figure 4, performance curve for a 4-stage boiler feed pump rated 450 GPM, 100 feet and 71% efficiency and 3,550 RPM. The temperature is 350 Fahrenheit. Required rated capacity in pounds per hour and head in pounds per square inch. So at 350 Fahrenheit, water density is 55.6 pounds per cubic feet. So the specific gravity now is 55.6 over 62.4 or 0.891. The flow rate is GPM times 500 times the specific gravity. Remember, 500 is 8.34 or 33 times 60. Saan galing yung 500? Yun. So 450 times G 500 times 0.891 is 200,475 pounds per hour. So ito yung answer mo. Yung flow. Record ba yun? Yan. Rated capacity, head, and feet. Plus also find the brake horsepower. So hindi lang nalagay sa required. Okay. So this at 350, yan dyan yung density, hindi 1. Okay. So ang flow rate mo is, at that is 450. Ang mass flow rate mo is yan. Given yung GPM nung pump. Kasi ang normal niya is, sa curve is yung gallons per minute. So actual mo, yan makukuha mong flow rate. So the head and PSI is specific gravity times 62.4 times head and feet over 144 para sa maging PSI. So 0.891 times 62.4 times 1,000 divided by 144 is 36.1 PSI. Okay? Bakit? Bakit 62.4? Kasi itong figure mo is puro sa 62.4. Kinuha mo yung mass flow equivalent mass flow rate kasi at any temperature, pagtaas, baba man yan, ang flow rate, mass flow rate mo, constant yun. Kaya kinuha mo lang yung volume ang iba. So, required volume mo is 500. So, yan. So, flow rate mo is 450 GPM yan. So, 1,000 feet. So, yan ang rating ng pump mo. Since volume to, so kunin mo yung ano niya sa mass flow rate is yan. Then, head in PSI. So, ang ano mo is, hindi pala. Ito pa si specific gravity. Okay, okay. Tama. Specific gravity times the standard density of water. So, yan. Okay na. So, 386.1 PSI. So, this is the answer. So, mali, mali. So, yan. Tanong lang. So, the head and feet is ito. Specific gravity times yung mass is gamma QH. So, the density yan. So, 891 times 62.4. So, this is the 36.1 PSI. So, this is your head. So, the brake horsepower is GPM times NP times head times specific gravity divided by 3960 times efficiency is 450 times 1,000 times 0.891 over 3960 divided times 4.71 is 142.6 horsepower. Okay. This is the pressure and PSI. Ang end head, so that is still 1,000 feet. So, kinonvert mo lang sa PSI. So, pag standard, so hindi yan. So, this is magiging 1 times 62.4. Yan ang PSI mo. Yan. Now, the pump, so ano siya. So, 450 and 142. Okay pa rin. Ganun pa rin. Kasi GPM and feet times and then specific gravity over efficiency. So, bababa yung ano mo. By specific gravity yung head mo. Okay, yan. Imbes na 450, 140, 450, 1,000. This is the rated. So, 450, 1,400, 200 yun. This is 150 sa taas. BSP at 60 Fahrenheit to. Okay? So, dito naman BSP at at 350 Fahrenheit. Yan. So, iba yan. Okay? Ayan. So, neglect mo na to. So impeller contour, there are 4 types of impellers, the radial, letter A, ito, or conventional, Francis, ito yung Francis, sino po Francis dyan? Then mixed flow and axial. So the pictures of figure 6 will have to visualize a high speed Francis screw bend impeller letter A, mixed flow impeller letter B, and a propeller type impeller letter C. So wala tayong makakuha ang color dito. Baka meron sa internet, hanapin nyo doon. May mga picture yan. Colored. Roger impellers noon, mahirap maghanap. Ngayon, malapit na. Maraming image sa internet. Radial impellers should not be confused with radial vanes. The fluid enters each type of the impeller in axial direction. So, however, the direction of the fluid is changed in the conventional impeller from axial to radial. A large part of impeller is radial so that the ratio of the outside diameter to the diameter of the impeller ay may be as much as 3.5 to 1. So sa fluid machinery, meron dong mga proportion ng sizing sa impeller blade. Some of head developed by wheel is due to the centrifugal force. So radial impellers are used extensively in power plant pump for they will develop it in excess of 300 psi per stage at 3,600 RPM with a flat characteristic curve. Francis impellers are similar in shape to radial impeller except for the straight radial section, with the lower discharge to eye diameter ratio for the Francis type. The development is also lower, but consequently, the speed may be higher. Also, the characteristic curve rises more sharply from full load to shut off. Mixed flow impeller discharge the fluid in partial radial and partly axial direction. Some of the head developed by this type of runner is due to the pushing action of the vanes and some is due to the centrifugal force. The mean discharge diameter of the impeller may be about equal to or the eye impeller. Next, the impeller discharge from propeller type of impeller is in the axial direction. So most of the head developed is due to the pushing action of the blade. Like the mixed flow impeller, propeller pumps are used for low heads and therefore primarily for circulating water service. So Francis in larger impeller may have been made in double suction design as in figure 7 to increase capacity and to improve hydraulic balance. Sa shafting, the ball suction impeller are the two equivalent of two impeller placed back to back. They have twice the capacity of a single suction wheel. Next, specific speed. So the concept of specific speed has been developed for design purposes to show the relationship of head capacity and speed. The specific speed of an impeller may be defined as the speed in revolution per minute at which a geometrically similar impeller would operate to develop 1 foot of head when displacing 1 GPM. It is customary to give the specific speed of an impeller for design conditions. Since specific speed is a function of wheel proportion, it is a constant for any group of impeller having similar angles and dimension. All wheels with the same specific speed would have the same efficiency except for variation due to viscosity of the fluid. The specific speed ns equal to n times the square root of q over s exponent 3/4. So ns specific speed, q is measured in gallons per minute. Remember this. H is the head and feet for one state. Q is for double suction impeller. Is taken as one half the total flow for the impeller. Kasi yung yung per impeller ka. So kaya yung Q mo hahatiin mo pag sa total flow, sa double suction. Sa multi-stage naman, di-divide mo to ng total divide by ng number of stages. So this is for English units na. Check nyo na lang yung fluid machinery para sa SI. So the specific speed for any impeller, one impeller calculated throughout its head curve would range from 0 to infinity. Each of the type of impeller has been found to have a range of a specific speed in which it will give the best performance. Larger impellers have a specific speed up to 3,000 RPM, while Francis wheels go up to 4,500 RPM. So mixed flow Impeller range from the specific speed of process wheel to about 10,000. For propeller types, the range is 10,000 to 14,000. Okay? So, ito yung figure na to, malapit lang dito. Malapit sa katotohanan, is galing lang sa internet. Okay? Ayan. US unit. System head curves. A head curve for a centrifugal pump is shown. So, note that the pump curve will coincide with the system head curve at one point during operation. So, itong pula, this is the system curve. Yung Bernoulli, knowledge, etc. Yun. Diba? And ito, blue, this is the pump curve. Yung pump naman. So, pag under operation, so magtatama siya. Tali. Therefore, the pump would always operate at this point unless some means of control were used. There are two methods of controlling a centrifugal pump, yung throttling valve and a variable speed operation of the pump. Okay? Variable yung speed binabago-bago through variable speed controllers. Variable speed. So the following formula for calculation of variable speed performance where RPM1 over RPM1 2 over RPM1 is equal to the square root of H2 over H1 is the cube root of SP3 over SP1 for constant fluid temperature and constant efficiency. Any convenient unit such as gallons per minute or pounds per hour may be used for quantity and feet per second per hour may be used for head provided that the ratios are dimensionless. Okay? So, hanggang dito lang yung pump. More on this topic as nasa ML Lab, ano yun, sa Dr. Bin, nasa fluid machinery, saka power plant. Okay? So, this is not the end of this topic.